Good morning. How about the clarity of the presentation, the audibility and the visibility?
Good morning, sir. Audible and visible.
Okay, we will directly start today. The file input outputs using using Prolog programming language. File IO means you can create text files and save your intermediate processing or the final output or whatever you wish to save. You can keep saved your results or the things being processed by the Prolog program, or else you can feed some data inputs from external file. Say it's a CSV file, comma separated file. That means a kind of a text file. So you can feed data. For example, if you have developed an algorithm which needs some data to calculate and process and compute and produce the result, so outcome. So in order to that, maybe not one or two data, maybe thousands of data may require to analyze. So in that case, so we are not in a position to it will be not practical to include these data to the Prolog program itself. So we prefer some external source, so external file, such as what we call. So here I am writing sample program. Okay, where we have stored these. Okay, I first I'll take a copy of this. File IO or something. Open up that using a text editor and copy and paste this program. Okay, so this program is to read from a file and write to a file such as text file. Okay, so the first part is the user-defined function write to file to create a file. So this file term, you can see it's starting with capital F, and this is starting with capital T. That means these are variables. So the arguments or the parameters are to be fed to these what we call arguments of two arguments that we define into this what we call program, this function. So there are two variables inside the variable. So this is the implementation. This is the abstraction of the interface of the function. So this is here's the implementation. Implementation open, write, close, write. These are open, write, close. These are keywords. Okay, you can see these are starting from simple. Oh, of course, this is also starting from simple, but it's not a keyword to be recognized by the compiler itself. So these open, write, and close are the keywords of the known things for the compiler. So again, this stream is a variable. NL means the new line characters, are something like \n in Java or other languages. So there are three variables: file, text, and stream. Okay, these are user defined variables. So this particular function will responsible of creating a text file if doesn't exist, and put something on that and close that. Okay, or read from file, that means if you uh, if you guide to the program that you have to locate this particular text file or whatever the extension, so you access that, you open up that, and you read line by line, character by character, then create a stream. So stream means a kind of a uh, character array. Okay, in this case, stream means is a continuous character array. So you need to keep that in the buffer, or you need to read one by one, and finally you can get the meaning of the whole thing by just by concatenating or combining these the individual characters found in this stream. So I have defined another user-defined function called read file. This time only one argument. File means the file name with its location. It's also a variable of argument. So open close get char open read close until. These all are not until. This is a comment. Okay, open read get char and close. These are keywords. Okay, so open file we locate means with the file name, extension, and the file path. Read is a keyword, and stream means what? Analyze character by character, incoming characters and character. Those are till the end. We accept one by one character. Okay. So get char, that means this is a function which recognizes or identifies each and every individual character found in the stream, incoming stream. Again, I have defined another user-defined function, process stream. Consider character by character and append that to the stream. Okay, stream to be analyzed. And finally, once we done reading all the characters, we can close the stream. Literally means closing the file. Once we have opened up the file with stream and started character by character and character by character, then append that characters to the stream and process the stream. Okay, therefore once you done everything, so we can close up the file. So literally closing the stream means closing the file. So there's a third function that means the process stream. So this is, since this is a user defined function, so this is the abstract form. Abstract form means this is the kind of the justify, just appear here the function name is appearing. Somewhere else we need to implement this process stream function. We need to define the logic or the business logic or the internal implementation of this function process stream. Here I implement the process stream. That there also we have two arguments, characters. Char means a variable, that means individual characters, and a stream. How to process the incoming character array or character stream. Here again I use write char, get char, and here I call the same function again. Why? That means I am using recursion, very powerful feature included in most fascinating languages, most rich languages. So why I have used this recursion instead of using a loop? Because loop is somewhat having big. If you aware of this big O notation. That means the complexity measure of the algorithm. So increasing the algorithmic complexity, that means having a large value for the big O notation, or omega is not good. It's not favorable, because that will drop the performance. So instead of using a loop, kind of a for loop or while loop, in other programming languages, we often use this do while loop. So somewhat till the end of file, till end of the file, we usually use while loop. While within brackets, exclamation mark EOF, that means end of file, do this reading. Okay, do this analytical thing. Here we don't do that. Instead, I have used a recursive approach. I have adopted a recursive approach. So this is to consider the next character. We read the first character, we analyze the first character and append that to the stream, and we take the next character and we append to the stream. Again, the second character becomes, that means the position, the index of the second character becomes again initialized. Then the third character will be taken to consideration. So accordingly, this continues till we find no characters in the stream. That means the end of file. End of stream means end of file. So then we can close. Once we done it, that means once we all the characters are taken to consideration, analyzed and appended to the stream over the buffer, so we can close the stream. That means literally closing the file. So I think I have explained this. Now is the time to so here's another thing you have to notice: the terminating condition of the recursive procedure call. What happens if you don't specify the terminating condition? So this will become again kind of a never-ending loop. Okay, the program will get stuck. That means we'll be running forever. So what is the terminating condition for this recursive procedure call? That is end of file, EOF. Okay, end of file, end of file. So this is a keyword. Okay, end of file. So these nothing means, this underscore means nothing. That means if we find nothing in the stream, that means we have come to the end of the file. So this exclamation means cut. Cut means abort. Okay. Okay, it's time to run this this one. SWF Prolog. Say if we have the compile statement, which is not necessary for Windows users, file io.pl. Okay, true. No warnings even. Program compiled successfully. Okay. Then I want to test the program. How to test then? How to test? There are two user-defined functions. We can call them one by one. First, I am testing this write to file. Write to file means what? We can create here. You can see there's no file named my file. Okay, text file. So here I am going to write or create a file called myfile.text.txt. That's a text file that I am going to create. Okay, and inside that, once you open up that, we should see some sample text written into the file. Write to file. What's going on here? Write to file. Unknown procedure, right to file, it shouldn't be. Right to file, it was there. Let's see. What's wrong with that? Probably the file location not allowed to create the file. Could not correct goal. That means what? Right to file. Okay. My file, say .txt, comma, some text. Unknown procedure. I think there's kind of a compile error or something. We haven't saved this. We haven't saved this before compilation occurs. Later we save and close this. Okay. Otherwise, it will be not in a position to. Okay, true. Then we call again this one. Then it's true. Okay. What has happened here? We couldn't save the file. So my file.txt has been created. If you open up that, some text inside that, some text is written. Okay, successfully completed the file creation and writing. So just an example here, I have written, I have created a file and I have appended some text. So in practical life, what you can do is you can store your intermediate processed data or your output. The final output can be saved for future use. So you have calculate just the average of some value set, some numbers. So you can keep save that for the future use. And I am now going to test the other thing, what we call the other function, user defined function, that is read file. So now I want to read that read file. We have to call by the name of the file that we have created. My file dot txt. Okay, some text means the content of the text file we have just created. So this is an example how we can save your valuable data, processed data or semi-processed data, and how to fetch. That means how to open up and how to read the text file, or and alternatively you can read a CSV file which consists of a large amount of data. So you can read real-time data even coming from a sensor kind of a thing and process them. So this is the example of the basic file input. So we will go for an advanced example. So this is not file IO, I think. Yeah, this is something different. Okay, this is not file IO. This is obtaining the user input. That means unique. Once you develop the expert system, so what is the basic feature of a typical expert system? Is that keep asking questions. Okay, keep asking questions, and the user has to respond. That means provide answers based on the user's responses. The expert system will come to some conclusions, so make decisions referring to the knowledge stored. So here what we are trying to do is we are trying to build kind of an interface so that can ask questions from the user and obtain the input and keep analyzing them. So I create a file here. User input. Okay. Then I just copy this. I do some slight changes. Since I am a senior lecturer now, so I copy this one here, and here this has been developed for the what we call Southeastern University. So here I change it to whatever non-context. So he is an instructor. Two designations. Instructor I must be simple. If you don't use double quotes, then you have to use simple lowercase attributes. Okay. Simple program. Find job title. It's a user-defined function. So job title also user-defined function which has two arguments or two parameters. The name followed by the designation or the job title followed by the name of the corresponding person. So I have used different styles: single quotes, double quotes, and no quotes. So all the three styles are accepted, but if you forget to, or if you are not using either single quotes or double quotes, you have to start the what we call the entity with the lowercase letter. So job title is a user-defined function. Within the user-defined procedure called find job title, I have this job title which has reference to these two facts. These are facts. These are kind of facts. Okay. These are kind of facts. So this is a user-defined function which directs you to which allows you to find the job title. And once you call this function, no need to pass parameters. Then it will ask a question: whose job you wish to know? That will ask a question to the system. For an example, if you're developing an expert system, the system will ask you a question. Then you have to specify the name of the corresponding person. Then the program will search for the matching results and let you know. So we will compile that. First of all, we will save that. Otherwise, what will happen? You have observed what has happened to the previous example. Okay, so user input time. Now we're going to compile this. Difficult to find this compiling statement because yeah. User input true, no warnings, no errors. Then I can ask this question, call the procedure, find job, sorry, find job title. That's all. That's all means no arguments to be passed. Okay, it will ask a question. Whose job title do you wish to know? This is a user defined text. Then you can answer. If you answer as Suneth and dot senior lecturer. Okay, you can ask the same question again. This time you said Prabhat. Okay. Dot full stop. That means a punctuation mark. Something wrong here. It should be instructor. Something wrong with here. I need to diagnose this carefully. Shall we make this capital and see what's happening here? No, it's not giving the correct answer. Something wrong with the program. Something wrong with that. I need to determine that. Okay, exercise 2. So today I have to stop from this point because I have a meeting at 9 at university. So I have to go there. I have to take my breakfast and get prepared and go to the university because I'm having a special appointment there, meeting there. So we will stop for today at this position. So these lab sheets have been emailed to you, and you can do by yourself, and the screenshots of the results, so how to call the procedures and the expected outcomes, everything is mentioned. Okay, so you can follow by yourself even. So please go through, and we will meet by next Monday morning. Okay, thank you and have a nice day. Thank you for your cooperation.